Metamorphic rocks, here we go. So, metamorphic rocks, metamorphism means change. So, that is when an existing rock is changed by hot temperatures and pressure of the rocks overhead pushing down on it. And this will lead to partial melting. Metamorphic rocks need to have partial melting, okay? If it's complete and total melting, it becomes an igneous rock again, so that's important. And this here, when there's really hot temperatures and pressure together that causes partial melting, we call this regional metamorphism. There's two types of metamorphism, and regional is when this happens. So, for instance, this is an igneous rock, angular interlocking mineral crystals, and then after it's undergone all of the pressure and high temperatures, the metamorphic rock may look like this. Notice how there's some sort of order or pattern. So we will often say that there's mineral alignment here. They're all aligned sort of like this, or this texture is called foliation or being foliated, and it can be called banding when you have different colored layers, and I'm going to show you that. So these are all metamorphic terms that we use for this mineral alignment. So for instance, here's an example. I have this photo showing slate. Slate is a metamorphic rock, and here the foliation is all like this. It looks like pages of a book, okay, but this shows us that this has been metamorphosed, and this is the foliation that I'm talking about. You can even see it down here, so that's cool. That's slate. This is extreme foliation, and this is banding. So, and you see that when you have the different colored layers here. It has sort of a striped appearance. Let's look at a close-up here, and you really can see. So this will say, mineral crystals that are not random. They're in some sort of order or pattern, and in this case, it is banding. This is extreme metamorphism, high-grade metamorphism. Here is a photo from a Regents exam showing band, because sometimes it can get kind of wavy like this. So this shows banding, as do these hand-drawn pictures. Not as good, but also from Regents exams, they demonstrated banding in this case. So just to give you an example of it. So this section, this is on page 7 of the reference tables, and this is the metamorphic rock chart. These here, highlighted in yellow, are all of the foliated metamorphic rocks, all the regional metamorphic rocks. So you see, it says foliated here, and it also says mineral alignment. So this is all of this is foliated, and then these are mineral alignment, and then this is banding, which is the different colors. And it's really the metamorphic rock gneiss that has banding, and it is the high-grade metamorphism. So this has undergone the highest temperatures and the most pressure to get that banding of gneiss. So the other type of metamorphism is contact metamorphism. Contact means touching, and that is changed by hot temperature only. So that means it's touching something that's very hot, usually lava or other rocks that are really hot, and that will metamorphose the rocks too, and sort of like cook the rocks, we say. But what you get here is usually non-foliated rocks, because you don't have all of that pressure pushing down on it to cause the foliation. So where we see these on the reference table are the bottom part. These 5 that are listed here are non-foliated metamorphic rocks, and you can see the type of metamorphism here. So contact, Hornfels is contact, and it says heat in there. And then these down here, these 3 are either regional or contact metamorphism. It depends. I do want to point out, especially for these down here, the comments are really important, because this will sort of, quartzite comes from sandstone, the parent rock is sandstone. Marble comes from limestone or dolostone. That's important. So sometimes you have to look here and really get into this chart. So here are some examples of some Regents questions. And it says the photograph below shows the texture of a rock composed of various minerals as seen through a microscope, magnified 20 times. The question is this: which rock is most likely shown above? So from this picture, you should recognize that there is some sort of order or pattern. They're all kind of flattened in this way. And from there, you should know to look for a foliated metamorphic rock, and that is schist. So you use the reference table to find a foliated metamorphic rock, and that should be the answer. So here's another one. So it has igneous rock and metamorphic rock, and it's very similar to the diagram I just showed you, to show that these sort of diagrams come up again and again. Describe the texture shown by this metamorphic rock that indicates it could be schist. Okay, what is the texture? Now, if you don't have it out of your head, you can use a reference table like this. Go here. You have to go to metamorphic rocks. Find schist. Schist is right here. So, and then you can look, well, where does it say texture? Texture's right here. So you could write mineral alignment or you could write foliated. Those terms will definitely work, and those are really your best answers. So mineral alignment, foliated. Okay, so you see how that works? Here's another one. Which geologic process is occurring to cause this conversion? So always look here. So shale, that's a sedimentary rock, clastic texture. This is metamorphic slate, and then schist, and then gneiss. So it gets increasingly metamorphosed, stronger metamorphism as we go this way. So which process is this? And the answer here is going to be metamorphism. So this is one of the more straightforward questions, I think, about metamorphic rocks, but just some examples of what you may see.